Hello students, welcome to aimsindia online classes. This is a chemist session. Here we are discussing about the classification of elements and the periodic table. In the earlier sessions we have seen different concepts about this periodic table and the different names given for the elements in the groups and periods, and even about the trending of atomic properties of the elements in the groups and periods also we have seen in the earlier sessions. Now here we are going to discuss a Olympiad practice sheet on this chapter on the periodic table. Okay, let us start that. First, let us go through the level 1 questions from this. See the first one. Which one of the following is most reactive? So, by giving certain elements, some elements, and if they ask to find out which is having greater or lower property, we can understand that there will be a certain relation between the elements given in the options. If you observe here, the elements given fluorine, chlorine, bromine, and iodine, we know these all elements belongs to same group. They all are from halogen group, seventh year group, isn't it? Now, if you observe these all elements, out of these, fluorine is the element with the highest electronegativity. So, as being a small sized atom and with the highest electronegativity, this fluorine will be more reactive among these all. Okay, next one. Which one of the following will show non-metallic character? Here some elements are given. Identify which is non-metallic element among these. We know iron, nickel, and the last one gold. It is Rm. These three are metals, isn't it? Only non-metal among these is bromine, and that too it is a liquid non-metal, isn't it? Bromine is the only non-metal which exists in the liquid state at room temperature. So bromine is a non-metallic element and it is liquid non-metal. So the next one, what do we call the horizontal rows in the periodic table? What do we call them? Yes, the horizontal rows present in the modern periodic table are called as periods, and the vertical columns are called as groups. Now here it is asked about horizontal rows. They are called periods. Next one. Which one of the following has largest atomic size? So which will be having largest atomic size among these four elements? Let us try to relate these elements based upon their positions. If you see sodium, magnesium, these two are at the extreme left side of the periodic table. Whereas if you see aluminium and phosphorus, these are at the right side of the periodic table. These two are at the left side. So we know in the periodic table from left to right, size decreases for the elements. So right side elements are having smaller size than left side elements. Now, now these two will be having the greater size, and in between these two, we have to compare now. First, which element will be there? Sodium. Next to sodium, there will be magnesium in the periodic table, isn't it? If we compare their side places, first there will be sodium in the third period. Next to that, there will be magnesium, and in the third year period, there will be aluminium, silicon, and phosphorus. This is the position of these elements. Now, how can we relate these four elements? These all are in the same period. In a period from left to right, atomic size decreases. Now, the starting element or the alkali metal will be having greater size in any period. Now, among these, what is a alkali metal? Sodium. So, sodium is having the greatest size among these all. Got it? Next one. Which one of the following has highest ionization energy? Observe here also the relation between the elements given in the options sodium, potassium, lithium, rubidium. What relation do they have? Yes, they all belongs to same group. These all are called as alkali metals. They present in the first year group, isn't it? If we positionize those, first lithium and then sodium, next potassium and next rubidium. Of course, there will be cesium and francium also will be there. Now, these are the positions of the four elements in the modern periodic table in the first year group. Now, they're asking ionization energy. We know in a group from top to bottom, ionization energy decreases because size increases gradually from top to bottom. So, the first element in this group will be having greater ionization energy among these all. What is the first element here? Lithium. So lithium is having the highest ionization energy among these all because it is the smallest sized element among these. Ionization energy is inversely proportional to atomic size. So as lithium is the smallest atom among these all, it has greater ionization energy. Next, identify the transuranic elements among the following. This transuranic means the elements which are after the uranium in the periodic table. The elements with the greater atomic numbers than uranium are called transuranic elements. Generally, these are radioactive. So, if you observe here, the element which is being after uranium, that is called transuranic, that is neptunium. Neptunium is the element which is present after the uranium in the periodic table, and hence it is called transuranic element. Okay, next one, element with atomic number 15 and mass number 31 is present in. Now, here they are asking the location of an element in the modern periodic table by giving its atomic number and mass number. Simply, we can say the position of any element by knowing the electronic configuration of that element. So here they have given the atomic number, so we can write its electronic configuration based upon it. What is the atomic number given? They have given 15. So if you write the configuration for that, 1s2, 2s2, then 2p6, 3s2, 3p3. So based upon this configuration, we can say it's a group number, period number, and the block to which it belongs, and even subgroup also we can say. All we can say from the electronic configuration of that element. If you observe here, the number of valence electrons gives its group number. Listen this carefully as it is very important concept, identifying the position of the element in the periodic table based upon its configuration. One among them is identifying group. Group can be identified based upon the number of valence electrons. The number of valence electrons gives its group number. If you see for this element, there are totally 5 valence electrons. So its group number will be 5. Now we can say its group number is 5. Next, period number. The number of shells existing in its configuration gives its period number, or the highest shell number existing in the configuration gives its period number. If you observe, the highest shell or the greater shell for this element is a third shell, isn't it? Because it has three shells: first shell, second shell, and third shell. So third shell is the highest shell. So this gives its period number. As third shell is greatest shell, its period number will be 3. It belongs to third period. So fifth group, third period. What will be the answer now? Here it is, group 5, third period. And even we can say the subgroup and block also. If you see the differentiating electron presence subshell, or the subshell in which the differentiating electron or last electron of that element present gives its block. For this element, the differentiating electron is present in the p subshell. So this element comes under p block element. Okay, it is a p block element as its a differentiating electron is present in the p subshell. And if the subgroup or if the block is s block or p block, then subgroup will be a. Okay, if the block is d or f, subgroup will be b. Now for this element, block is P block. Then what will be subgroup? A. Now we can say its group number is 5A or 15th group. It belongs to 50A group and third period in the modern periodic table. Okay. Next one. Which of the following sets of atomic numbers belongs to alkali metals? What are alkali metals? First A group elements are called alkali metals. What are those? Okay, we know in the first group there are hydrogen, lithium, sodium, potassium, rubidium, cesium. These are first group elements. If you see the atomic number of first element, what is the first element's atomic number? 1. And lithium atomic number 3. And if you add the number of elements present in the second period, it gives the atomic number of next element. Means if you add 8 to this, we get the atomic number of next element sodium. And the number of elements in this third period is 8. So for this, if we add 8, we get the atomic number of next element, that is potassium atomic number, that is 19. And we know in the fourth period there are totally 18 elements. If you add 18 to this element, to this number, we get the atomic number of next element. So 18 plus 19, total it is 37. So rubidium atomic number is 37. Okay, see where these atomic numbers are present. And if you find you want to find the atomic number of cesium without remembering, we know in the fifth period also sorry, in the fifth period also there are 18 elements. So if we add 18 to this 37, we get the atomic number of next element cesium, that is 55. See, now these are the atomic numbers of the elements in the alkali metals group: 1, 3, 11, 19, 37, and 55. So where these atomic numbers are given, you see once in the which option? I think it is here: 37, 19, 3, and 55. Of course, except hydrogen, because hydrogen is a non-metal. The remaining elements are alkali metals. Okay, if you observe, these four are there in the second option, so it will be correct answer. Okay, next one. So the next question: which of the following elements has maximum metallic character? What is the relation between these all elements again? Lithium, nitrogen, sodium, phosphorus. If you locate these elements in the modern periodic table, then we can say easily about the characteristic asked. First, lithium. Down to lithium there will be sodium. And if you see nitrogen, in the same period along with the lithium, it is at the right side. And phosphorus in the third period along with the sodium and down to nitrogen. So this is the position of these four elements in the periodic table. Now we know metallic character from left to right, it decreases. So these elements are having lower metallic character than these, even though these two are non-metals actually, isn't it? So these two are metals. Now in these two, which is more metallic, we have to identify now. We know in a group from top to bottom, metallic character increases because size increases. So the one at the bottom will be having greater metallic character. What is that? Sodium. So sodium is more metallic among these four. Okay, in that way we have to derive the relation between the elements, and hence we can identify which is having the greater or lower property. Next one. As per the modern periodic law, the physical and chemical properties of the elements are periodic functions of their. Yes, what does it explain us? Modern periodic law. It explains that the physical and chemical properties of the elements are periodic functions of their atomic numbers. Okay, based upon the atomic numbers, later electron configuration is also taken into consideration. But the principle is given as the physical and chemical properties of the elements are periodic functions of their atomic numbers. Okay, next one. Which of the following properties generally shows a decreasing trend along a period. So what will be decreased, they ask, which will be decreasing in the period of the modern periodic table. If you observe atomic size, what happens to atomic size in a period? We know in a period from left to right, atomic size decreases. So it decreases. Next, electron affinity. As atomic size decreases, electron affinity increases. Atomic size decreases in a period. What about ionization energy? Ionization energy is also inversely proportional to size of the atom. As atomic size decreases, ionization energy also increases in a period from left to right. Even electronegativity also increases because size decreasing. Now, the only one property that is decreasing in a period from left to right is atomic size. I think you know why it is. Why atomic size decreases in a period from left to right, even though the atomic number of the element increases. Because all the elements in a period are having same number of shells, and their nuclear charge gradually increases from left to right. And even the outer shell electronic cloud also increases from element to element, one extra electron is being added. So between these two, electron cloud and the nucleus charge, attraction increases and hence size shrinks. That's why in a period from left to right, atomic size decreases. Okay, next one. Which scientists come up with the concept of periodic table that included all the known elements at the time? Yes, he was Dmitry Mendeleev, who succeeded to classify all the available elements at the time into a tabular column. Before him, many scientists they have tried to classify the elements, but they were not able to classify as per their principle all the available elements at that time. But for the first time, Mendeleev has done that. He fit all the available elements at the time into his periodic table. So he was Dmitry Mendeleev. Next one, read the given statement and mark the correct options. See the first statement here. Alkali metals have least value of ionization energy within a period. Is it correct? Yes. If you observe the elements in a period from left to right, atomic size decreases and hence ionization energy gradually increases in a period from left to right. Now, the first elements are having the lowest. What are the first elements in each period? Alkali metals. So alkali metals are having least value of ionization energy within a period. So this is correct statement. Next statement, if you observe, they precede halogens in the periodic table. Is it correct? They are in front of the halogens? No. They are in front of noble gases. So before the alkali metal, there will be a noble gas at the right side. After the noble gas, they come alkali metals. Okay, this is incorrect. What will be the correct answer here? Statement 1 is true, statement 2 is false. Okay, next one. The law of octaves was proposed by who proposed the law of octaves? Newland. Newland proposed the law of octaves. Next, on descending a group, the periodic table, what happens on going down the group in the periodic table? Let us see here options. Electronegativity of elements increases. Will it happen? Before that, let us compare the size so that we can relate these all properties to the atomic size. In a group, from top to bottom, if we move, atomic size increases. If size increases, electronegativity decreases in a group from top to bottom. If you say ionization energy, even ionization energy is also inversely proportional to size of the atom. As in a group from top to bottom, atomic size increases, ionization energy also decreases, not increases. Metallic character of the elements increases. Yes, as the size increasing, the tendency of losing electrons increases and hence we say metallic character increases. See the next one, size of the elements decreases. No. What happens in a group from top to bottom? Size increases because the number of shells increases element to element as we move down, and hence size of the elements increases but not decreases. The only correct statement is this: metallic character in a group from top to bottom increases. Next one. Now we are going to see the level 2 questions from this. See the first one. Which of the following position of elements have same number of valence electrons as that of element of atomic number 6? What is the element with atomic number 6? We know element is carbon. So without knowing the element's name also, we can predict its position because atomic number is already given here. So if you read the electronic configuration for this element with atomic number 6, we get it as 1s2, 2s2, 2p2. Now let us try to predict its position, means its group and period in the periodic table. How to say the group number we told? Based upon the number of valence electrons. This element with atomic number 6 has totally 4 electrons in its outermost shell. So it belongs to group 4. And what its period? Period number is given based upon the shell number, the maximum shell number in that configuration. If you see, it has 2 shells. So second shell is the highest shell. That gives its period number. So it belongs to second period. Now what they're asking, let us say also, which of the following position of the element have same number of valence electrons as that of the element atomic number 6. Okay, so to be with the same number of valence electrons, those elements should be in the same group. The elements present in one group, in a group, will be having same number of valence electrons. Now here we found it, the element with atomic number 6 is present in group 4. So group 4 or 14th group, isn't it? This carbon belongs to group 14, or it is called group 14 also. So the remaining elements which are present in the same group 14 will be having same number of valence electrons. What are those? This, and here this. These three will be having same number of valence electrons. What will be correct answer now? 1, 2 and 4. Where it is? Here. Okay, this is correct answer. Got it? Next one. Match both the columns and mark the correct option from the codes given below. See the matchings here given. So in the column 1, they have given certain property. And the elements with the highest of that is given in the column 2. Try to match this. Highest electronegativity is for fluorine. The element with the highest electronegativity is fluorine, isn't it? Element with the highest electron affinity, we know it is chlorine. Instead of fluorine, it is being chlorine with the highest electron affinity. We have known why it is also, because of smaller size of fluorine. Next, highest electropositivity. The element with the highest electropositivity is cesium, isn't it? And next, highest ionization energy is for helium. Now, where it is given correct answer is C. First, A should be connected with 3. A connected with 3. Here it is. So this is the only answer. Let us cross check the remaining also. B 4. Yes. C 1. Yes, it is. And D is 2. So it is the correct answer. Check once. Okay. Next question. Read the following passage and answer. P, Q, and R are 3 elements with atomic numbers Z-1, Z, and Z+1 respectively. Q is an inert gas. Identify the group to which P and R belongs. Oh, here they have given some hypothetical elements and their atomic numbers. And among these, one clue is given. Q is an inert gas. Suppose, so Q will be at the extreme right side of the periodic table as it is being inert gas. Okay. Now the element with the atomic number, it is having the atomic number Z, it is given there, and the element with the atomic number Z minus 1 is P, so it will be just before that. It is a element with atomic number Z minus 1 because Q is Z, and the next element is Z plus 1. We know the element after any noble gas will be an alkali metal. It will be in the starting of the next period. So we can locate R here with atomic number Z plus 1. So it is a noble gas. Q is a noble gas which is in the 8th group or 8th A group or 18th column we can say. And this P is just in front of that, before that Q. So we can say this is 7th A group. 7th A group elements are called halogens. So P is a halogen and R is just after the Q, so it will be in the next period alkali metals group. R is a 1A group element or alkali metal. Now what they are asking here, identify the group to which P and R belongs. So P belongs to halogen group because they first given P. So P is halogen and R is alkali metal. Where it is mentioned? Here it is. P is halogen, R is alkali metal. Got it? Next one. Match both the columns and mark the correct option. See the columns given here. Try to match this. Scientist names and their contributions are given here. Dauvergne. How did he classify the elements? Dauvergne classified elements into triads. That is law of triads. Newland, law of octaves. Mendeleev, he given his periodic table based upon the atomic weight of the elements, isn't it? Next, modern periodic table is given based upon the atomic numbers of the elements. Now see the correct matching. A is connected with 4, where it is here. So this is the correct answer. Let us cross check once the remaining options also. B 3, okay. C 1 is okay. This is a correct answer. Check once the matchings. Okay. Next one. In the periodic table, the metallic character of elements. What happens to the metallic character in the periodic table? Metallic character, it increases from top to bottom in a group. In a group, atomic size increases as we move down. So as atomic size increases, the tendency of losing electrons increases, thereby metallic character increases in a group from top to bottom. And it decreases in a period from left to right because size decreases. Tendency of accepting electrons increases but losing tendency decreases. So we can say metallic character in a period decreases from left to right. Now let us see options what they have given. First one, if you observe, decreases from left to right across a period on descending a group. Something missing. If you observe the next one, decreases from left to right across a period and increases descending a group. Yes, this is correct, isn't it? In a group, it increases. In a period, it decreases. That is metallic character. Okay. Okay. Thank you for watching our video. Please subscribe our YouTube channel and press the bell icon for receiving latest updates. And visit our website aimstoday.in for any information regarding online classes, quizzes, live worksheets, do it yourself activities, English classes, and even for watching coding classes. Okay, thank you.